In this video, you will learn to describe why comprehensive cybersecurity architecture can be very complex to implement in reality. Translation of simple business requirements into technical specifications and deployment decisions can be very difficult. The protection mechanism itself is subject to attack. Protectors have to be right all the time. Attackers only have to be right once.
An additional challenge to the security ecosphere has to do with the complexity of the solutions. So the first point about security not as simple as it seems is a huge understatement. Our customers frequently have very simple requirements. For example, one requirement might be that all users will authenticate to the enterprise. Sounds easy enough, but when we start looking at the implementation and the engineering behind a comprehensive access control system with role-based access control or perhaps attribute-based access control and privileged users and archiving, right, the solution gets very complicated, even though it's got a very simple high-level requirement. You see this all the time. It is part of the security professional's job description to take these somewhat simple requirements and being able to decompose them into accomplishable or achievable modules for that. An additional complexity for a security architecture is the fact that the solution itself can be attacked. There's the principle of the security enforcement point, or SEP. The security enforcement point is a technical implementation of a business policy. For example, as we were just talking about access control, is that the business security requirement is all users will sign on to the system. The technical implementation of that might be for strong authentication, right? Something you know, something you have. The tracking of privileged or system administrators, right? Somebody can change a security policy. So we have technologies, we have software, and we have hardware, we have firmware that implements or delivers the technical solution to these business security requirements. That's the definition of a security enforcement point. Well, if the salient point is that the adversaries, the attackers, know that to get to the information that they're after, that they need to defeat the protection mechanisms. They need to breach the moat, scale the wall, break the gate, right? So these enforcement structures are just as much a target as the actual data itself. It's a level of complexity that's not found in other technical disciplines and one that we very much need to be aware of within the security world. And as we pointed out, the protection of this security enforcement structure not can but will complicate the solutions, because you've got this additional layer of protection in terms of protecting the protection mechanisms. Some additional challenges that face the security professional has to do with our security architecture decisions, right? So we talk about logical architectures that describe more what we're doing as opposed to how we're doing it. Right, and so then we start getting into the topology of this, of where these enforcement mechanisms will be placed within the architecture. You know, for example, generally we want access control technologies closer to the perimeter, closer to the DMZ. However, some net flow sensors may be more towards the center of the enterprise. So there's some architectural decisions, there's trade space studies, there's trade-offs, there's risks and benefits for these decisions. And it takes a seasoned architect to be able to help define where these deployment decisions will place these technologies. Second point, we talk about key management being very difficult. So when we talk about key management, we're talking about cryptographic keys. You remember the earlier diagram with Alice and Bob, and that Alice would encrypt or protect her message before putting it onto the transmission channel. A cryptographic system uses a key And there's a corresponding key in Bob's domain for him to decrypt that message. So the key management of the creation of those keys and the distribution of those keys, which we will look at a little later, is a very complicated solution. So something to keep aware of with that. Then there's this larger principle that we as the defenders have to be right all of the time. So the dynamic attacks that are out there that change every day, every week, right? The security architecture needs to be flexible enough to be able to protect against those attacks 100% of the time. So people, places, things, time, and money, all of which are in play in terms of having a dynamic security architecture that protects the information, protects the enforcement points against these constantly changing elements. And they have to be right all of the time. You know, a security architecture that protects 90% of the time is not going to be well embraced by any business. However, the attackers really only need to be right once in order to succeed. So you see the disparity, the imbalance, the disproportionality of success between attackers and protectors. The business line generally considers security a necessary evil. There's a principle about the seatbelt philosophy. A seatbelt costs about $200 to put into a vehicle, but that 1/2 second before a serious automobile accident, that seatbelt is worth more than $1 million. Security constructs are exactly the same thing. The business lines frequently considered to be security in the way. It is incumbent upon us as security professionals to ensure that the security constructs are actually enablers, right? That we make it easier to conduct business in a complex world. Our last set of challenges, and of course these are fairly high level, but can be decomposed into additional challenges. Talk about the constant effort, the afterthought for security, and that security is frequently viewed as a obstacle. So somewhat in reverse order, that the business lines within a enterprise frequently view security as an obstacle, as a barrier. This is something that is a necessary evil, and we need to operate, and just do our best to get. And that encourages, by the way, people to try to do end runs around security. Security professionals' responsibility is to make security an enabler, right? So make it a positive value. This helps us do business in a very complex and very threatening world. We'll talk more about that a little bit later. So why is security sometimes viewed as an obstacle? Is the fact that it's not integrated early into the life cycle, the development life cycle or system life cycle development for the project. So we look at life cycle models such as our RUP model or iterative engineering, and you don't see security in the functional definition. So the security professional needs to convince the project leaders that this is the least expensive way to integrate security into the approaches to be included earlier. So that way you'll have application developers, infrastructure, our security people there, test engineers, QA, all of those have a place early in the table. The top point about security architectures requiring constant effort speaks to the dynamic nature of our attacks, that the adversaries are constantly introducing new attack profiles, new vulnerabilities are released from our software manufacturers that are turned into exploits. Just the war changes, and it changes every week. So constantly, our defense mechanisms, our security architectures also need to be very mobile, very agile to adapt and to change to these changing attacks. Otherwise, we'll be very much like we were back in the 1990s with very static castle, moat, drawbridge type of security architectures.